about that. So Mr. Cunningham had a big impact on me in fifth grade. Mrs. Rapp was my kindergarten teacher, and I still remember her to this day. And when I was in 11th grade in high school, Mr. Turner was the one who really was my great teacher. And I think that as you guys are in school, you should always be thinking about which teachers are those that really taught me things that I am going to pass on to other people someday. Okay? Because that's what I love about teachers. And so everything that I'm talking to you about is pretty much passed on to my teachers. So what I'm going to do right now is I'm going to share screen, and you're going to be looking at the face of Aristotle. Now, Aristotle lived, I think, in like the late 300s BC. And Aristotle was the student of a great mathematician called Plato. So Plato, not Play-Doh, some of you have heard me talk about Plato before, was a great philosopher and mathematician. And then Plato had a teacher called Socrates. Now, we don't know much about Socrates because he never wrote anything down. The only thing that we know about him is what his student Plato wrote down. So it's really interesting that the only reason we know about this great teacher named Socrates is because of this wonderful student named Plato, who then had a wonderful student named Aristotle. Now, what's really cool about Aristotle, do you know who his student was?
They tell them to be.
Can you give us a hint? Because I swear I know this one. Can you give me a hint, Mr. Kramer?
I will give you a hint. The person was known as the greatest military general of all time, of history. And his name has 3 parts. The middle word is Jonah. What do you think?
Oh, Alexander the Great?
Yes,
I knew it.
And Bayram, is that what you were thinking?
Yeah, but I wasn't 100% sure.
Yeah, but you know what though, Bayram, take a chance. The worst thing that can happen is you get it wrong and I hit the what button, guys? The eject button. And then Bayram goes right through his roof and he comes out in his backyard. No, there's no eject button. Even if you get it wrong, it's not a big deal. So now, I want to tell you about Aristotle. First, I want to tell you what he did wrong. Aristotle was proved about 2,000 years after he made these theories, these guesses, these conjectures. They proved that he was wrong about gravity. And Galileo is the one that proved Aristotle was wrong. And Galileo was punished for it. He was punished because everybody thought that Aristotle was the greatest, smartest person in the world. And maybe he was. But guys, do you know that even your teachers, your parents, your grandparents, everybody makes mistakes, correct? So Aristotle is no different. And so Aristotle studied physics, biology, philosophy, and of course, mathematics. And one of Aristotle's favorite things to do was to play with oblong numbers. So guess what? We're going to talk about oblong numbers today. And first, I'm going to define it for you. Oblong numbers are the product of 2 consecutive integers. So for instance, if I said to you, The first number was, let's see. I'm going to try this. The first number was 9. Well, it's the product. Who knows what the word product means? Go ahead, Caroline. Caroline, go ahead. And everybody, by the way, everybody right now, unmute yourselves, because when I asked Caroline, she had to first find the unmute button, and I want you guys to just be able to talk. Okay, go, Caroline.
It's like if I was doing like 8 plus 1, 9 would be the product because that's like the answer.
Ah, now 8 plus 1 equals 9. Not, Caroline, you were so close. 9 is actually called the sum. Everybody say that?
Sum.
So sum, Caroline, sum means addition. It means adding two things together. Difference is subtraction. Quotient is the answer to a division problem. But product is the answer to what? What's left over? Go, Tess.
The answer to a subtraction problem.
That would be a difference. Subtraction would be a difference. Mark?
Multiplication.
Everybody go like this if you had multiplication. Everybody go like this. So product, everybody, is multiplication, and therefore 9 times the next consecutive number. What's the next consecutive number after 9? Say it out loud, guys. What number comes after 9?
10.
Right. So everyone, 9 times 10 is the 9th oblong number, which is what? Go.
90.
So 90 is an oblong number. And I'm going to share with you now, we're just going to go to entire page, and I'm going to hit this little button here. And so the first oblong number, that is a positive number, is the number 2, because 1 times 2 is 2. Now we're going to do this as a team. Nobody go ahead. I'm going to say something times something is, and I'm going to go 1, 2, 3, and then you say it, and nobody yells. Deal? Thumbs up if that's a deal. Okay, great. Here we go. The second oblong number is 2 times 3.
6.
6.
Awesome. The next oblong number is 3 times 4.
12.
Please wait till my 3 fingers come up, guys, because sometimes other people have to process a little bit slower, like me. Sometimes I like to think a little bit slower. Okay, the fourth oblong number. 4 times
20.
5. Wait, no. Remember, I just said you have to wait for the 3 fingers. On 3, 1, 2, 3.
20.
And the next one, 5 times 6.
30.
And 6 times 7.
40. 42. I mean 32.
32, 42.
32.
Okay,
42.
okay, nobody
42.
yell it out. Nobody yell it out. This is very important. Whenever we have a disagreement about numbers, we don't argue about it. We prove it. And so what I like to do is I would actually create an oblong rectangle of 6 by 7. Now notice that one of the ways I like to do it is I like to count by 5s. Are you guys ready to count by 5s?
Mm-hmm.
Let's do it. 5,
5, 10, 15, 20, 25, 30, 35.
Wait. Now, you did. Let's see how we did here, guys. And I want to make sure that
36.
oh, wait a minute, guys. We have a little problem. Mr. Kramer made a mistake with his rectangle, did he not?
Yeah, oh, I saw that. I think. Yeah, me too.
You see
Yeah.
the mistake? So
Yeah.
watch this. I just made an Aristotelian mistake. And so I am going to remove this and I am going to draw a new rectangle because my rectangle was off. That is a 7 by 6. And now I'm going to go back and do another 5. Please count all the 5s with me again. Go. 5,
5, 10, 15, 20, 25, 30, 45, 40,
and 40 what?
42.
And that, folks, is 6 times 7. Now, there are many, many ways for you to do 6 times 7. Everybody, let's count by 6s. Ready? Go. 6,
12, 18, 24, 30, 36, 42,
Stop right there. Stop right there. Stop right there. Once you look at your fingers and you see 7 6s, you know that you're done. Now we're going to do 6 7s. Isabella, you ready to start this? Let's count by 7s. Go. 7,
14, 21, 28, 35, 39, 42.
No, guys. After 35 is 42. That's the 6th 7. So there's many, many ways. The only way that I don't like to count to 42 is by 1s. I would count by 2s. I would even count by, I would count by 3s. Maybe I would count by 14s, definitely 6s, definitely 6s.
12s.
But I also think,
Oh, no, not 12s. Oh, my God.
that, guys, don't you agree? By the way, 14s, that would be. Don't you agree that it's fun to think of different ways to multiply? But to just memorize 42 is really not that much fun, but it's necessary. So once you do break the number down, it's good to be able to know that 6 times 7 is 42 without even thinking. Now, 3 on 3, 7 times 8. 1, 2, 3, don't yell it.
66.
And 56 is correct. The next one, 8 times 9. Don't yell it, just say it. 1, 2, 3.
72.
72.
Finally, you already know 9 times 10.
90.
And 10 11s, just think 10 10s plus
110.
110.
Now, these are the first oblongs. Now, I want to ask you a question. Let's say that you were looking at a number line. Let's say that you were looking at a number line and you were looking at the numbers 90 and 110. Who can tell me what number is directly in the middle between 90, don't say it out loud, 90 and 110 on a number line? What number is that? On 3, 1, 2, 3, go.
100.
Okay. Who can tell me what number on 3 is between the numbers 2 and 6.
Four.
Right in
Four.
please. Guys, look at me in the eyeballs. It's very important that nobody calls out. My rules are you wait 1, 2, 3, and everybody does it because some people need more time to process, like me. If you're like me, you're going to need a little more time to process. So the middle number between 2 and 6, go.
Four.
Four.
Now, what's the middle number between 20 and 30 on 3? 1, 2, 3.
25.
Now, can you tell me what these numbers all have in common? What's going on with those numbers? 4, 25, and 100. They're very, very special numbers. They're very. And Zach, I'm just muting you because you've got feedback on your line, like maybe there's like an extra computer open. It's probably an internet issue. And when you need to talk, just unmute yourself, okay? Now, and Bayram, you do the same thing. Unmute yourself now because you're muted. Good. Now, guys, does anybody see anything special? You know, I have an idea. Let's do one more. Find the middle between 6 and 12. Find the middle between 6 and 12. And on 3, 1, 2, 3.
8.
9.
Eight.
It is definitely not 8 because now guys, think about this. Quiet, please. 6 is 2 away from 8, and 12 is 4 away from 8. But 9 is 3 away from 6 and 12. Now, Mark, do you want to make an observation?
No, I was thinking that 4, 25, and 100 are all even, but 9's also not.
Yeah, and 25 is odd also. Who wants to try to find the middle between 12 and 20?
16.
Oh, come on, Bayram. You have learned from me not to call out. It's a very important rule. All right, on 3, guys. 1, 2, 3.
16.
16.
All right, now the next one's going to be a little harder. Between 30 and 42. Don't call it out, please. Jack, if you sit up, you're going to be way more correct. Now, guys, I have a little hint for you. When you're trying to find the middle number, if you add up the two numbers, 30 plus 42, and then you take half of that answer, that gives you what's called the average. Just like 20 plus 30 is 50, half of that is 25. 12 plus 20 is 32. Bayram, I'm going to just mute you because there's noise in the background. So 30 plus 42, half of that, everybody, on 3, 1, 2, 3, go.
36.
And what is the average between 42 and 56? Don't say it out loud. Don't say it out loud. So you've got 98, which you now have to divide by 2. And David, are you working on this? Yeah, put that fidget down or whatever that is. And here we go, guys, on 3, 1, 2, 3.
49.
39.
You want to repeat somebody's wrong answer? Or do you want to say what you know is correct? Somebody said 39 and it was repeated.
Oh, did I get it wrong?
No. Just let other people think.
49.
It is not 39, it is 49. So if you hear 39, that doesn't
get around.
mean it's correct. It means that that's one person's answer. Now the next one, you're gonna have to add 56 plus 72 and take half of that. That's 128. So do not call it out, please. Good. And on 3, 1, 2, 3, go.
64.
Awesome. And finally, if we add 90 to 72, we get 162. Who can tell me half of 162? And just think about using your short division where you just go 2 goes into 16 and 2 goes into 2. On 3, 1, 2, 3.
81.
81.
And now, can you tell me what all of these numbers have in common? It's a special sequence of numbers. I'm going to go with Jonah on this.
Wait, no, I didn't mean to raise my hand.
Okay, because that looked like a raised hand. Mark?
They're all square numbers.
Guys, these are the square numbers.
That's
So
what I thought.
guys, the average of any two consecutive oblong numbers is going to give you a square number. Pretty amazing. Now, when I look at these numbers, guys, I like to put them on a graph. I like to draw my numbers. When you draw your numbers, you draw them with rectangles. 1 by 1 square, 2 by 2 square, 1, 4, 9, 16, 25. Look at the first 5 oblongs. The first 5 oblongs is 2, 6, 12, 20, and 30. Who knows what the next oblong is? Don't say it out loud. On 3, 1, 2, 3, go.
40.
42.
42.
Very nice. 42, which is your 7 by 6 oblong rectangle. And I want you guys to have some fun creating huge oblong rectangles. So for instance, I'm trying to figure out what would be the biggest one I could create. And if you guys go to page 4, go to page 4. 2, 4, 6, 8, 10, 12, 14, 16. It looks like that is 18 across. So you would have to go 18 down. And then one more to make 19. And I'm not sure if I grabbed it correctly. No, I didn't, but I tried. Let's try again. Let's see. I am going to, and maybe you guys could do it even better. So we know that that's 18, and then I have to go one more to 19. So this is an 18 by 19. Now, what I would like you guys to do is draw at least 4 oblong rectangles inside, and then I want you to write the oblong number in it. So for instance, if it were me, I might just do 5 by 4, and inside that, I would write 5 by 4, and inside 20 and circle it. So I want you guys to do at least 4 of them, and then do more and more and more. If you're done, do 5, do 6, do 7. Claire?
Can you go back to the page with all the square numbers quick?
That one?
No, the one that we just saw with with 2, 6, 12, 20, and 30. Yeah,
Okay.
I noticed that it's going up by 2s, but it doesn't start with 2. It starts with 4. It goes 4, 6, 8, 8, 10.
Oh my gosh. Guys, are you watching what she just found out? Claire, that's amazing. Claire, everybody go like this if you're liking it. If you're liking it. Claire, that was an awesome observation. And oh, wait a minute. Has anybody looked at the square numbers too?
I noticed that too.
Yeah.
What did you see? Do you see a plus 3?
3,
Plus 5?
5,
Plus 7?
7, 9,
9.
Mr. Kramer, I noticed that too. 11.
11.
Hold on. Now somebody said something about, go ahead. Somebody just said something to me and I couldn't hear them.
I noticed that too, Mr. Kramer.
You're what?
I noticed what Claire saw too.
Oh, good. And guys, how many of you now see that between 4 and 6 and 6 and 8 and 8 and 10 and 10 and 12 and 3 and 5 and 5 and 7 and 7 and 9, do you see that there are always 2 in between? And it is true. It is true. So can anybody share with me the oblong that they created? I won't be able to do everybody's. Jack, why don't you go first? Since your pencils are up here, I assume you're done. So what do you get? Jack, what'd you do already?
Huh?
What did you do? What oblong rectangles did you create? Penny, what oblong rectangles did you create? Asher, what oblong rectangles did you create? Tess P, what kind of oblong rectangles did you create?
I'm still doing that.
Okay. Gabby, how about you? Sabrina. And how about we can do Hayden?
I'm still working on mine.
Okay. Tess M or David O, Isabella K, Olivia. Excellent.
I don't get what we're supposed to do.
You're supposed to do exactly what I did. You're supposed to draw an oblong rectangle and then name it. I just drew a 6 by 7. And I'm going to name it as 42.
Mr. Kramer,
Yes.
why are you, how come 4 and 5 are 20?
Well, 4 5s, 5, 10, 15, 20, or 5 4s, Mark, 4, 8, 12, 16, 20. A 4 times 5 rectangle will always have 20 square units. Some of you are fortunate enough in your house to have windows that have 5 across and 4 down. That's a beautiful, does anybody have that in their house? A 5 by 4? Most of you will have 3 by 4s, which is also an oblong number 12, but a 5 by 4 oblong is really cool. I really like that one. Is anybody ready to share their oblong? Go ahead, Tess P.
I did 4 by 9 and I named it 36.
That is a true statement, but that is not an oblong rectangle. Remember, it has to be one number and then the next number after it. So 4 by 5 or 9 by 10 or 8 by 9 or 3 by 4? You want to try again?
Yeah. I'll do 6 by 7.
Beautiful. And a 6 by 7 is what?
Is
And I'm gonna,
42.
oh man, you are awesome. Awesome job. Caroline, what about yours?
I did 3 by 4.
And what'd you get?
I got 12.
And you definitely got 12. By the way, if you write the dimensions 3 by 4, that's what real mathematicians do. That's what Aristotle did. And that's what you did, Caroline. Who's going to go next?
Mr. Kramer,
Yes, sir, Jonah.
I did 8 by 9.
Oh, dude, can you tell us before, wait a minute, hold on. 8, 9. Can you tell us what that oblong is, my friend?
It's 72.
Wow. So, so cool. I love it. Bayram, do you have one for me? Penny, Zach, Claire, Sabrina? Come on, who's ready for us? Come on, Jack, what do you got? Oh, Jack, you have your hand raised, buddy.
Well, no, I just have a question.
Yes,
You can
go.
name it anything you want.
Anything as long as it's oblong. Remember, it's a number times the number next to it. So you could do 12 by 13 or 8 by 9.
Oh.
That's what an oblong number is. Okay? Great question, buddy. How about you, Olivia? Penny, what about you?
I did 2 by 3.
And what'd you get, Sue?
I don't have the page, Mr. Kramer. I have the.
You don't need the page. You just need to draw your rectangle, buddy.
I
I
did.
don't have any graph paper, so you can't see the.
All you have to do, if you watch this, Bayram, just draw a 4 by 3, and you can either write the number 12 in there, or you can separate it into 3s and 4s and count them. There's always a way to do that. So go ahead, Penny.
I got 6.
You definitely did get 6. David, why don't you share?
I did 9 and 10.
Do you mean 9 by 10?
Yeah.
Yes, we say 9 by 10. 9 by 10. And what did you get for a 9 by 10, my friend?
I got 90.
90 is perfect. 90 is perfect. So who's got one more for us? Gabby?
I've done 3 and I got 11 by 10 is 110. 7 and 8 is 56, and 4 and 3 is 12.
Wow. Well, I have to tell you, I love your 11 by 10, and I think I've drawn it correctly, although I'm not 100% sure. That's 110. And what about you, Hayden?
I did 1 by 2.
Oh, you know, that everybody always forgets about 1 by 2. It's kind of a neglected oblong number, but to me, it's one of the most beautiful oblong numbers. And what, of course, did you get for that one, Hayden?
2.
Very nice. Caroline?
I did 5 by 6.
Oh, and what did you get for 5 by 6?
30.
And I think, guys, that's all the room I have on this guy, but 5 by 6 is a really cool one. And Tess P?
I did 12 times 13, and I got 156.
All right, hold on a second now. I've got to do this one in purple because it has to go over the other one. So what did you say, 12 by 13?
Yeah.
Of course, Tess, you chose one that really challenged all of us. Oh my God, I think I got it. And tell me what you got again.
156.
Wow, that is a beautiful
Mr. Kramer.
12 by 13 oblong. Now, Jack, you had a question? And Jack, keep yourself unmuted so you don't have to worry. When I call on you, you then can just answer. Okay? Go ahead, Jack.
So I did 3 by 3.
Well, 3 by 3 is a square number, not an oblong. But what is your 3 by 3?
9.
Excellent. That's a square number, not oblong. Oblong would be 3 times 4, Jack, or 2 times 3. Jack, give me another oblong. I just want to make sure you understand what oblong numbers are. Go ahead, Jack. Hey, guys, if I had 100 on the bottom, what would I have going up?
101.
100.
Nice. If you were thinking 101, say it. So Jack, do you understand it's got to be the number and then the next number? In fact, I'm going to show to you a different way. Are you ready? Everybody stop working and look up. I want you all to draw an oblong rectangle. Remember, it can't be a square because oblong rectangles are always one off. They're always one off. Now, on the bottom, on the side, I want you to write the letter N. Now, N equals the smaller of the two dimensions of the oblong rectangle. So if N represents the smaller one, do not say it out loud, but write down what the longer one would be. If N, and N could be any number. It could be 5, it could be 10, it could be anything, but we're just going to call it a letter N for number. What would the other dimension be if this were oblong? Don't say it out loud. I want you to write it down. And this is where we begin to talk about the world of algebra, one of my favorite places to go. Now, how many people, raise your hand, wrote down something for that longer dimension? How many people wrote down something? Raise your hand and keep your hand up. I have 4, 5, a few more. All right. Now, I want to ask you, Hayden, I'm going to let you tell me what you came up with for the longer.
I did 6 for the longer one.
Well, you don't know that the shorter one is 5. All you know is that it is N. Just replace the number with a letter N. Now, watch this, Hayden. Let's go with Gabby.
I wrote down the number 10.
Yeah, but then we don't know that this is 9. So
Yeah.
you can't write down an actual number. Mark?
I wrote O.
Oh, I
As in
like
the alphabet.
that. I like that because O does come after N. But guys, let's say that N were 3. What would this guy be?
4.
4. Let's say that N were 18. What would this guy be?
19.
19.
let's say that this guy was just n. What would that guy be?
Oh.
The bigger N?
N plus what, everyone?
1.
Oh.
Yes, guys, it's just n plus 1. So all we have to do is add one more to that dimension. If we were doing a square, here's a square. If I told you that one side of a square was n, what would the other dimension be?
N plus 1?
No, this is a square.
N minus 1.
No, this is a square.
N.
No.
It's just n, because in a square,
N.
the area of the square is n times n, which we say is n squared. That's n times n. Now here, for the oblong, we're going to have to be a little creative. We're going to have to do n times n plus 1. Everybody write that down. N times n plus 1. And Jack, I don't see you writing it down because I can see both of your hands. I want to always see your arm moving, and that way I know you're writing. It's a really great skill to develop. So now, if you wrote down n times the quantity of n plus 1, I want to let you know that this parentheses means multiplication. And using something called the distributive property, have you all ever heard of the distributive property?
Yes.
Some people are saying no, some people are saying yes. All that means is we are multiplying n by n, and then we're adding that to n times 1. So let's do that together. Who can tell me what is n times n? Go ahead and say it if you know what n times n is.
N.
N. N.
N times n, it's right there.
N plus 1.
N plus 2.
N squared.
It's n squared. N times n is n squared. Then we have to add n times 1. Who knows what is n times 1?
N.
On 3. 1, 2, 3.
N.
N.
So guess what, guys? If you have one dimension of an oblong number, all you have to do is square it and then add that number to it. So watch this. If I want the 10th oblong number, all I'm going to do is substitute 10 for n and 10 for n. Who can tell me what is 10 squared or 10 times 10? Say it out loud on 3. 1, 2, 3, go.
100.
And who can tell me what is 100 plus 10?
110.
And do you remember we got that as 10 times 11, which was the 10th oblong number? What if we did something crazy? Here's my formula, n squared plus n. And I'm going to let n equal 100. You ready? So I'm going to let n equal 100. So I need to do 100 times itself plus 100. Now, I want you to write it out. Most people, when they do this in their head, they get the place value wrong. I want you to write it out. And if you don't pick up your pencil, there's no way to do this. So Jack, pick up your pencil, lean forward, and write it out.
Wait, are we doing 100 squared plus 100?
You are, but you're not calling out the answer. You're just going to write it down. And that's literally going to be the 100th square oblong number.
Okay, I got it.
It's good, good. You don't, not everybody has to, you don't have to tell me when you got it. I'm going to just watch people. And when they're looking at me, I know they're done. And when they're looking down and they're writing, I know they're writing. So the first thing I want to ask you is, did anybody get the 100 times 100 piece? If you did, say that number first. On 3, 1, 2, 3.
10,000.
1,000.
1,000.
It's actually, guys, somebody said it correctly. It's actually
10,000.
You see the 2 zeros here? There are 2 sets of 2 zeros, which makes 10,000. And 10,000 plus 100 equals go.
What? 10,000. Wait.
100.
100.
10,100
10,100
is the 100th oblong number. Now, who wants to go crazy with algebra? This is crazy with algebra. We are going to we're going to do the 1,000, the 1,000 oblong number. So you have to square 1,000, and then you have to add 1,000 to it. Now this one's a lot of fun because you get to do 2 sets of those zeros. Jack, sit up and write what you're doing. Awesome. Good job.
Tens, hundreds, thousands, 10,000.
You guys, another minute. And sometimes what I like to do is just underline or circle my zeros so I know to give 2 sets of those when I'm squaring the number. So let's do 1,000 squared first. On 3, 1, 2, 3.
1,000,000.
200,000.
Million.
Well,
Million.
6 zeros following the 1 would be 1,000,000, but don't now forget the 1,000, and we add that. What do we get, everybody?
1,000,000, 1,000.
1,000,000, 1,000. And that is the 1,000 oblong number. Now, I have to tell you, I would find it really difficult to do this without algebra. Can you imagine doing that 1,000 times? Hayden, do you have a question?
No.
Okay, I thought I saw your hand up. So guys, algebra can be a lot of fun. Let's look now at one of my favorite types of numbers, which is called triangulars. Do you guys see how triangulars build by adding 2 to get 3, then adding 3 to get 6, adding 4 to get 10? Do you see how the triangular numbers are 1, 3, 6, and 10? Yes?
Yep.
And what would the next one be? Add 5, add 5.
10.
Add 6, add 6.
21.
7, add 7.
28.
28.
Add 9, add 8, add 8.
36.
36.
Add 9, add 9.
45.
45.
Add 10, add 10.
55.
55.
Now watch this, guys. This is amazing. I couldn't believe it when I discovered it. That what Aristotle did is he took two triangular numbers and added them. And what happened when he added two triangular numbers?
A square.
No, he did not. It's very close though.
Oblong?
He
A
got
rectangle?
an oblong rectangle. So the sum of the product of a triangular number and 2 will equal an oblong number. The first one, 1 plus 1 is 2. 3 times 2 is 6. 6 times 2 is, come on guys,
12.
10. 10 times 2 is,
20.
20.
and 15 times 2 is,
25.
30.
30.
21 times 2 is,
42.
42.
and 28 times 2 is,
56.
and 36 times 2,
72.
45 times 2,
90.
90.
and 55 times 2.
110.
And guys, this goes on forever. It's amazing how triangular numbers work. Now, the last couple of things I want to talk to you about are this. By the way, I gave you paper to create huge triangular numbers. One of my favorite ones, this one right here. I'm not going to tell you how big it is, but it definitely is the 20th triangular number, and I really love it. Now, guys, I want you to compare the square numbers. Remember, Jack, you were into the square numbers? 1, 4, 9, 16, 25. Help me.
36. 46. 49. 58.
4.
81. 100.
100.
And then oblongs. 2,
2.
2.
6. 6. 12.
12.
12.
20.
20.
30.
30.
30.
45.
42.
56. 72.
90.
110.
110.
can anybody come up with a comparison between the square numbers and the oblong numbers? So if you were to compare 1 and 2, 4 and 6, 9 and 12, 6 and 16 and 20, and so forth, do you see a pattern? Like I was really impressed
I know.
with the way, yep, don't say it out loud. I was really impressed with the way Claire came up with the pattern of oblong numbers on their own. That was amazing. And David, what are your thoughts?
Wait, for which one?
Well, 1 and 2 and 4 and 6 and 9 and 12 and 16 and 20. We're comparing square and oblong numbers. Can you find patterns? And Mark, did you raise your hand?
Yeah, I was thinking that they go up by 1, like 1 and 2, that takes 1 time.
That's all you're going to tell me?
Yeah, and then 4 and 6 too. 9 and 10.
So you have to add 2. 9 and 12, guys, you have to add what?
3.
3.
And guys,
4.
6, 7, 8, 9, 10, 11, 12,
5. 7.
8, 9,
9.
10, 11.
yeah, so guys, pretty amazing that, so if I told you that the next square number was 121, what would be the next oblong? Come on, wouldn't you have to add 11 to it?
Yeah.
Which would be what? 11 plus 121 is?
132.
Nice. And if I told you the next square number was 144, and then you'd have to add 12 to that, it would be what?
156.
156.
And remember that was the one I think, Tess P, that you did when you drew your oblong, which was really cool. And then what about 13 squared, which is 169 on 3. 1, 2, 3.
172.
172.
172.
182.
182. Now, in the last 2 minutes, I want to show you this, okay? This was one of my favorite lessons because I got to actually do them and build square pyramids, 3 by 3, 4 by 4, 5 by 5, 6 by 6, 7 by 7, 8 by 8. And I also got to build oblong pyramids, 4 by 5, 5 by 6, 6 by 7, and 7 by 8. Pretty amazing stuff, guys. If you have golf balls or tennis balls in your house, I want you to go grab them right now. Just don't open any cans. Don't open any cans because new tennis balls need to be kept pressurized. So don't open new tennis balls. If you have old tennis balls, you can build square pyramids or oblong rectangles and build pyramids with them. I actually use glue. You would only do this with your parents, hot glue to actually create blankets of squares and oblong numbers. And then I throw them around and they're a lot of fun. So I hope that you guys enjoyed the lesson about Aristotle and about his wonderful discoveries. But remember, when you get to middle school, you're gonna learn a big mistake that he made about physics and gravity. And I would be really interested to see what happens when you find that out. Everybody now say goodbye. By the way, do you know what Gabby's doing right now? Gabby, can you tell us what you're doing? This is so awesome.
I was counting how many people I saw on my screen at once.
Is there an oblong number in front of you?
No, because I have 3 times 3.
Oh, because I don't have an oblong either. That's too bad. I wish I had an oblong, but I don't.
I have an oblong. I have an oblong.
You do? What do you have?
I have 4. I have 4 and I have 4 and 5.
Wow, that's awesome. Well, listen, guys,
4.
I have to go to my elder students.
Then there's only 2 people.
I have to go to do you know that my elder students use canes? I'm just kidding. They're just 4th through 6th graders, but or whatever. They don't use canes, but I call them my elder students. And by the way, Isabella, that may be the cutest dog I've ever seen. Okay, guys, I love you guys. We'll talk to you next week. Have a great week. Bye.
Bye.
Bye.